Tell you what, GNC, can you get somebody in the back room to try to figure out what the equivalent delta V is we're getting so that we can see if we can backtrack to see if we can figure out what's venting? Roger, we'll give it a try, Flight. Okay.
When I looked up and saw both oxygen pressures, one absolutely zero and the other one going down, it dawned on me, and I'm sure Jack and Fred about the same time, that we were indeed in serious trouble. The only way to survive the situation was to transfer to the LEM.
Flight Econ.
Go ahead, Econ.
The pressure in O2 tank 1 is all the way down to 297. We better think about getting in the LEM or using the LEM systems.
I'd say this is as serious a situation as we have ever had in manned spaceflight. We've always called the LEM a good lifeboat under those circumstances. If at any time in the mission, however, the LEM had separated and we had gotten ourselves into a rendezvous situation or the command module being around the moon, then what you state is absolutely true. It would be a fatal situation.
Tell them you from Flight. Go ahead, Flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
The accident had occurred 200,000 miles from Earth. Lovell, Swigert, and Hayes rode in the lunar module attached to a lifeless command module. Apollo 13 had started as a mission of scientific exploration. It was now a matter of survival. Since the command module was dead, except for the oxygen and power hoarded for re-entry, the guidance platform of Aquarius, designed to land on and take off from the moon, would have to be used.
The first milestone, and I consider this after the accident, I guess, more or less the survival now, the first milestone was to get alignment on the LEM platform. Alignments are important, you know, because without knowing exactly which way the attitude of a spacecraft is in space, there's no way to tell how to burn or how to use the engines of that spacecraft to get the proper trajectory to come home.